And we were missing you yesterday too. Were you sick?
Yeah.
Feeling better? Good, good. All right. Okay, so we started 2.2 yesterday. Focus. Started 2.2 yesterday. There's quiz 2.1, 2.2 when the 2.2 notes are done. So that's possible that you may see that quiz tomorrow. I don't know. You need to be familiar with these skills. All righty. So we were talking about reference angles, and I had given just enough information to thoroughly confuse Kylie here, right? So let's unconfuse you because that generally happens given enough time here, right? So what we're doing, this is the whole gist of what we're doing. You're going to be given an angle, okay, that is beyond 90 degrees. And you're going to think, where does it terminate? And we know how to find where they terminate, right? If it's something 700 something degrees, you just keep subtracting 360s. Or if it's in the negatives, you keep adding 360s until you get an angle that falls from 0 to 360, okay? And then you can eyeball it, right? You can look at that number. If it's 240 something, you know what quadrant it terminates in, correct? So once you've gotten it down to just between 0 and 360, then you were almost going to know what's happening.
To the flag
Of the United States of America
and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Now the Texas flag. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one indivisible. Now please remain standing for a moment of silence. You may be seated. We do not prompt doors open on the campus for any reason ever.
Never.
If the door prompts open, please close the door for our safety. And keep
Close those doors.
your ghost code. If there
No,
is
close the
any,
door.
please send it to-
Yeah.
Isn't Kylie's shirt so awesome and everybody
Grade 6 through 7 can come out for junior high year, and grade 8 through 11 can come out for varsity year.
that shirt going,
Sign up until this Friday.
You must have
Today's National Philly Answering Message Day and National
designer
Code Day.
clothing paper.
Today's quote of the day. Do the best you can, and please know better. And when you know better, do better.
Stylish,
Thank you. Have
You
a
look-
good day.
loved. Is that good enough? Are you happy now? So you bought her the sweater, right? Y'all are so cute. Okay, moving right along. Okay, everybody say hello to Mackenzie. Y'all say hi to Mackenzie.
Have a good day.
Okay, if you're not hearing this message, Mackenzie, shame on you. Okay, so anyway, all right, so here's the deal. Once you get your angle in position, you're just finding how many degrees it is from the x-axis. Okay, so how many degrees are between here and here? Well, I would kind of need to know this number, wouldn't I? All right, and the x-axis we're running back to, there's a trick for what you do in every quadrant. If they happen to give you an angle in quadrant 1, something between 0 and 90 degrees, okay? If you fall in that amount, then the reference angle is your angle. So theta prime, that's one way to say I'm giving you a reference angle, not the angle itself, actually is theta itself. They're the same, okay? So if you have an acute angle, it is the reference angle. Got it? But let's say you have an angle out here in quadrant 2. What would be our range of degrees in quadrant 2? Okay, I should probably put this in interval notation. So 90, but not including the 90 because you really don't do a reference angle for the quadrantals. Okay, so between 90 degrees and 180 degrees. Okay, so if you have a terminal side over here, where's the closest x-axis? What direction is it going to run to get to the x-axis? It's going to go down to here, right? Okay. So let's say that this was a 110-degree angle. And you want to know how far it is from that 110 to the 180. What could you do? You would take 180 minus your, I'm going to call it my theta, okay? Now, my theta may not be the original. I mean, like, look at this, negative 600, y'all. Negative 600 in my theta. I'm going to add 360s until I get a number between 0 and 360, and that'll be my theta, okay? Now, what if I'm ending here? Can you help me find an expression that would always help me find the reference angle here?
270
But 270 would have me running to a y-axis, wouldn't it? I've gone past the 180 this time. So it's going to be 180. No. It's not going to be 180 plus it. It's going to be, I'm just going to turn this around. I'm subtracting and finding a difference, right? But which one is higher? My theta is higher than 180 this time instead of my 180 being higher than theta. So I'm going to do my theta minus the 180. Because look, if I've already traveled 240 degrees, I just need to back off the first 180 and I'll see what's left, right? So let's say I end up over here. Can you come up with an expression to find how far I am from here? Yeah, 360 is the larger one. Minus theta is the smaller number. Okay, so we don't want reference angles to ever be negative, do we? So it's a pretty easy process to find a reference angle. Make sure you are used to the vocabulary reference angle, that you know what we're talking about. It's like saying, I got to run back to the x-axis. Okay, I'm playing tag. Somebody's close to get me. That's home base. I'm running to home base. Okay, so what if I have a 150-degree angle? If you need, you could sketch it if it helps you visualize. But what quadrant would I be sketching this in? Quadrant 2 somewhere, right? And so I need to know what is this amount. And so if I'm in quadrant 2, it's 180 minus the 150. You do not have to show me the scratch work. I would hope you could do a lot of this in your head, right? It's 30 degrees. Okay? So kind of what we're doing is we're just pretending the initial side is the closest x-axis. All right? So what about 312? Where would that guy terminate? Quadrant 4. So what's my scratch work going to be?
360 minus 3.
I want to know how far it is between the 360 and the 312. What y'all coming up with there? 48. Okay. Note that your answer should always be a positive. Oh, no. Coming up to here. Well, where is it that I'm looking for? I thought I had something that said a reference angle was always an acute. Oh, okay, here it is. It's the smallest positive acute angle. It's there. I just never highlighted it. I wonder if this blue highlights bright or just so dark. It's a positive acute angle. So could 90 degrees be a reference angle? Okay, y'all are just zooming ahead of me and not with me. Could 90 degrees be a reference angle? Because that's a right angle. It's not acute. Acute is between 0 and 90. So your quadrantals won't ever be asked what's the reference angle. Okay? So what we're going to do about this negative 100, is it ready to go? So the first thing we're going to do is add a 360, which gives us, and so 260 is my theta. Oh, backing up, back up. I really wanted to practice. What is it that we found? How would we label this? This is what we could call it. We could call it theta prime, or we could call it alpha, right? So I just want to do a little bit back and forth because it could be theta prime or alpha, okay? So over here, this isn't theta prime, that's theta, huh? So what am I going to do to find the reference angle?
Subtract 180.
I'm going to get 180 degrees out of there, which leaves me with what? 120 degrees. That's my answer. Let's call it, what do you want to call it? Theta prime. That's what this book calls it. But I just want you to be familiar. Maybe it'll be alpha. Now, what about this one?
260 minus 180 means 120 is not. I'm not sure.
We went the wrong direction. Okay, hold on. We are in the wrong quadrant. Are you? Where is 260?
No, that's right.
No, it's in the.
It's the
on
map.
This can't. This is not an acute angle.
Yeah, no, it's just we
25 minus
the math
18
was
says
just
7.
done wrong. Yeah.
Oh, we're borrowing. Oh my stars! I can't trust y'all. Okay, you, sir, need candy for paying more attention than I am. I mean, did I not just say it has to be an acute angle? It wasn't. It wasn't 280 minus 160. Thank you for keeping me honest. All right. So 16 minus 8 is 8. And it's just 80. Are we better? Okay, moving right along. What do I do about this one? Do I need to adjust it at all? Okay, so this is my theta, right? So what's my reference angle?
36.
Okay, let's say 36 is also, let's play with alpha because you're going to do some alphas this semester. You're going to do all sorts of Greek letters. And I think one of the things at the back of your, where did I put our notes? That we just finished? Okay, all the pages you were asking me the other day, Kylie, that I missed. I think somewhere in there, very, 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 very last thing in our Unit 1 packet is a list of the Greek letters. Okay, we've got lowercase and capitals. So this is a lowercase alpha. Okay, so we play with alpha, we play with theta, we played with pi for years, haven't we?
Wait, what does the alpha mean?
Same thing as theta.
Yeah, alpha is just if you look up here, you didn't watch video yesterday, did you?
No, I didn't have time. I plan on it. Next
I
year.
gotcha. Yeah, okay, so anyway, these are two different ways to just notate that you have a reference angle and it's not your original angle. Okay, what are we going to do about this 360? Adding 360 is not enough, is it? What if we added it twice? What if we added 720? How do you feel about that? Then we come up with what? Okay, now that is not the original angle, but that's going to be the theta we play with, okay? So I'm ready for a theta prime. What are we going to do to get that theta prime?
Subtract it from 180.
Okay, 180 minus 120 is, okay, 560. That's not one revolution. We just overshot it and just kept going around. What are we going to do? Subtract a 360, and we are left with 200. That's going to be my theta. 200, we've overshot 180, haven't we? So what are we going to do? Subtract the 180, and we were just 20 degrees past the x-axis, weren't we? It's time for another alpha, in my opinion. Okay? Now, we're going to our notebook because we got some problems out of the book, okay? So, notebook 2.2. Interesting, this is trig functions of non-acute angles. Section 1 was trig functions of acute angles, and we're obviously dealing with angles that are larger than 90 degrees, aren't we? All right. So we are going to look at the first little batch of problems is from 36 through 53. And they are simply asking you here to see if what they're telling you is either true or false. Okay? So these are true or false questions. So what they're going to do is they are going to hand you a trigonometric equation. How are you going to know if it's true or false? What makes an equation true? Both sides are the same thing. Well, obviously, they're not going to look like the same thing. So we're going to have to work both sides, see if we get the same thing. So we're going to do exactly one example of this. It's number 46. And it says, it proposes that the cosine of a 60-degree angle is equal to, what's something that we know the cosine of a 60 is equal to that would be, it would be what? Okay, okay. No, give me a different trig expression that we know is the same as cosine of, we could say sine of 30, but that's not what they gave us. They didn't give us that. So we're going to see something else that may be an identity. They have given me, oh, they went pretty crazy here. I lost it. I found it. Cosine squared 30 degrees minus 1. Are they the same thing? How are we going to check that out?
Okay, so the cosine of 30.
Yeah.
Square it.
Okay. All right. Well, hang on. Let's go ahead with the left side. So you already knew cosine of 60. So if I'm looking at my chart, to get to 60 degrees, I only go over 1/2. Do y'all agree with Filippo that that's a 1/2, right? And over here, I need to multiply 2 times the cosine of a 30 degree, square that puppy, and then subtract a 1. Agree? So now, if I'm going to a 30 degree, how far over am I going? Square root of 3 over 2. Anybody want to agree with that? Okay, square root of 3 over 2. I'm going to leave this 1/2 here. He's fine. So I'm going to put a little question mark because I'm really wondering, are these the same, right? So 2 times, what happens? Well, say that again. Okay, wait, one at a time. Kylie?
2 is canceled because there's a 2 on top of it. Or
Okay,
they
it's an
square it first.
you have to square it. It's an order of operations thing. So as long as there's an exponent, it has to be taken care of before that. Did you have a different question or did you have the same thing?
I had an answer.
Oh, you have an answer. What happens if I square the square root of 3 over a 2? Y'all agree? Got a 3 over 4. Then we need to subtract a 1. Okay, still working. What happens if we multiply 3/4 times 2? 6 over 4. Can we simplify that? 3 over 2. What if you have 3 halves and you subtract 1, which is really 2 halves? So, true or false? True. So, y'all just pause a second. You're gonna do a whole lot this semester where you've got to be able to quickly find any of the 6 trig functions for any of our special angles from a unit circle. And if you go on into calculus, you got to be able to do that. Okay? Now, that was 46. Next batch of questions is far away, 2 pages in the book away, and it's problems 71 through 82. You need to be doing the odd problems. That's all there is to it. If you come and I give you a quiz and you don't know how to do all this stuff because you only watched me do it, that's on you. Okay. Now, we're going to do a little bit of working backwards here. This is definitely non-calculator, all right? They want you to find theta, okay? So we're going to find all Oh, do I need to say angles? I completely lost the directions. All values. Okay. So there may be multiple answers. All values of theta. What do we use theta as a variable for? So we're looking for angles. Okay. In this case, our answers will be in degrees, right? All the angles that make this true. Okay. So we're working a little bit backwards here. So let's look at a few of these. 72. If I were to tell you the cosine of theta was, first of all, if you're starting at the origin on a unit circle, what does a cosine move look like? Right? But it could be moving to the left, right? How would you know if you move to the right or the left? So keep an eye, keep a close eye out for negatives and positives because you could totally wreck it if you go the wrong direction. Okay? So let's say the answer was to the cosine of theta, the answer was square root of 3 over 2. Okay? Now, in my vocabulary, I like to call those long, short, medium, or long. What's that? That's your, okay. I was thinking short, medium, or long. It's a long move, right? Okay. So if you were looking at an XY axis, you're going to be moving from here, what direction? Zero. Right? The long move, correct? Okay. Now you said 30, correct? So would you agree that a 30-degree would give you that answer? Anything else? I need to tell you something else about the directions so that we know who's got it correct. I left out a piece of instructions here. Okay. It also tells me, keep losing the directions here. We are on the interval. So I'm going to use interval notation from 0 degrees, which is included. So it could be 0 degrees. All the way around the circle. Where do you land if you go all the way around the circle? But we don't want to include the 360. You know why? Because it's the same thing as 0. Okay? So I have been given the option of calling this a 330-degree angle or a negative 30-degree angle. I just showed you more information. Which one are we going to go with? Can we approach it from here, or do we have to approach it by going all the way around? So what's this angle going to be called? All right. So by limiting us, they limited us having an infinite number of coterminal angles there, right? Okay. So my answer is that theta is equal to, in this case, 30 degrees and also 330 degrees. We will do this a lot. This is very similar to, I give you the angle and you find the ratios associated with it now, or the move associated with it, XY move. Now I give you the answer. You got to work backwards and think about where those angles could be. Okay. So number 74. Let's say I give you the secant of theta, and the other side of the equation says it's negative square root of 2. Well, the other day when we were working forward, what did I suggest you do with secants?
Flip them to their other one.
So what is the reciprocal of secant? Okay, so we have an algebra toolkit that we played with last year. And the most powerful tool in an algebra toolkit is, in my opinion, the ability to do anything you want in an equation as long as you do it on both sides. Do y'all agree with me? Here is a piece of that tool that you may have never thought about. Y'all look at me. If you want in an equation to get the reciprocal of one side, as long as you get the reciprocal of the other side, it's great. Now, I don't have a great notation. If I was multiplying both sides by 5, I'd wrap it in parentheses, multiply both by 5. If I was square rooting both sides, I would square root both sides. I don't have a great notation for reciprocal. So I just keep doing these little arrows, and you might even want to say, I'm going to recip. If I want to recip one side, I have to recip the other side, right? So what is the reciprocal of secant of theta? So now this suddenly becomes a cosine problem. What is the reciprocal of negative square root of 2?
2 square root of 2.
Okay, I'm going to write it down because I don't think my brain today is in a simplify it quickly mood. But then if I did decide to rationalize that, what would it look like?
Negative square root of 2 over 2.
Okay, is that a thing? That's a thing. So if I would benefit from visualizing it, I'm making a cosine move in the negative direction of square root of 2 over 2. Where would I draw my little arrows? Where could I terminate? Okay, I got some points to the left. I got a yawn and some mumble. So
Our angles are like 135, 225.
our angles are like 135 and 225. Now think about that. Are y'all in agreement? Okay, so theta, because I'm looking for my angles, is equal to 135 and 2. Why is this not? We did different problems last year. I was about to say, that doesn't look like the one in my notes because oh, no, I found it. I found it. Yes. But we never finished it. So 135 and what?
2 and 5.
Okay. I don't have it written down in my notes there. I don't know what happened last year. Probably the bell rang and then I came back the next day and didn't do that one. Let's do number 82. This time I want the cotangent of theta to be -1. And let's go in freezy mode, okay? Try it out. Now this one, you may be better off. Reciprocaling isn't really, it's not going to turn it into sine or cosine, is it? So do you have any thoughts?
Cosine over
I could say the cosine of the angle over the sine of the angle. I'm going to come back from freezy mode here since this one really was rather different. So the cosine of the angle and the sine of the angle, I haven't changed this into, I didn't reciprocate. I didn't make a change. I put something that's exactly the same on this side, right? Okay. So those two things are still equal to -1. What did we say the other day would cause tangent or cotangent? Why would a fraction over itself end up equaling 1 or -1? What makes a fraction equal 1 or -1? Same thing on top and on bottom. Do we have any places on the trigonometric circle where the x move and the y move are the same? Yeah, no. It's all your 45s.
Square root of 2 over 2.
Square 2 over 2, square root of 2 over 2. All right. So if my x move or my cosine and my sine move or my x and my y move are the same, then I'm looking at my quadrantals, right? But
Quadrant 2 and 4.
it has to be in 2 or 4. Why?
Because
This is positive, right? Negative and negative is positive. So it's got to be here. And so what are the 45s in those quadrants? 135, 315. Okay. All right. Oh, okay, I need to write. Then theta must be 135 or 315. So that wraps up the notes for here, and we are in pretty good shape time-wise. So let's go ahead and start on our 2.3 notes. I need you to expect this quiz to be tomorrow. Okay. Which is what, 131? All right, let's flip over and let's see how much I do in the notes versus in the packet. I think in our 2.3, we're actually going to start in the notes first. What I have, we're going to start in the notebook first. These problems are the word problems towards the end of the section. Let's take a quick look of what you're going to be expected. You've got some odd problems. There is a cat homework for 2.3. This is going to be due, I don't know. I'll have to see how long it takes me to cover it. Okay. But it's definitely not going to be due this week for sure. Okay. So set this aside and let's start getting some more information from 2.3, which is titled Finding Trig Functions with a Calculator. Trig functions with a calculator. So guess what you need to do as soon as you finish writing that down? Yay, go get a calculator. All right. Let me get myself switched over to the problems. You got a calculator getter. You going to be the calculator? You could be the calculator getter for both you and the other guy. I need to go rename this video because we got the two things. Just two calculators. All right, there you go. Here you go. All right. The first thing that you need to do, I need a calculator. First thing you need to do, so Felipe, are you familiar with these calculators? Okay. All right. Did you have a similar calculator, or did you just never use calculators much at all, or what? Huh? Okay. Well, there are some situations in the I don't like calculators. I like people to use their brains. But there are some situations, especially if you have a real life application where you just need a nice number, you know? So instead of saying, oh, square root of 3/2, you need a decimal value that you can apply. Okay, some of our sines, cosines, and tangents apply to triangles or formulas in real life situations, and your answer needs to be how many miles per hour you're going, and you don't need that to be, oh, I'm going 37 cosine of 24. You know, how fast is that? You know, so if all the speed limit signs on the highway looked like that, people would just be going all crazy. So sometimes we need a practical answer. So that means we need to know how to get this stuff into the calculator. And so first of all, angles are measured using what units? Degrees or radians. You're familiar with radians because you pretty much have already taken this class, but you guys aren't going to really get the exposure to radians until we get to unit 3. So this calculator, and pretty much any calculator that has sine, cosine, and tangent on it, any scientific calculator has to be able to work in degrees or radians. So you can change that, and you change it by this button right here that says mode. And there's all sorts of things that can be changed in that mode, but the default is radians. Y'all, until I taught trig, I kept thinking, why don't they put degrees first? All we ever use is degrees because I was teaching geometry, you know, but this calculator is really designed for higher level math. And once you pass up geometry, we only use degrees occasionally. We use it in these first 2 chapters. And then in the rest of the book, we usually will only use degrees if we have a triangle or a real life situation. But if we're working on the trigonometric circle, we're going to mostly use radians. So how am I going to get this guy into degrees? Go down, go right, hit enter, and you are in degrees. If you clear the calculator, it will go back to the default of radians. So people who use the calculators in my other classes may clear them every day. So always go back to this. In the Unit 1, Unit 2 test, the calculator problems are all in degree mode, and that ball is in your court. If you forget to set up your calculator in degree mode, your answers will be completely different, and I will count them completely wrong. So make a big old note. Degree mode. Put a bunch of exclamation marks around it. Maybe even highlight that puppy. You have got to be in degree mode here. Okay? So it is your responsibility. And when you are in calculus, it is your responsibility to assess the situation. Are they giving you angles in radians or in degrees if it's an opportunity where you could use a calculator? Okay? So got my calculator handy. First little batch of problems is 5 through 22. And what they're asking me to do is to use your calculator to find a decimal approximation. This is not super hard. They want it to be a decimal. And for precision accuracy, they don't want you to just round it off to the tenths or the hundredths. They tell you to go to 7 places. As you are working the Unit 1, 2 review, read every problem to see if they tell you where to round. If you don't round to what the directions say, you lose 1 point. All right? Now, what happens if they don't tell you where to round?
Go to 3.
Why do you go to 3?
Because it's your little Stewart standard.
It's my Stewart standard. So if there's no directions on where to round, then for this class, I always want you to go 3 places. Okay? My other class, they go 2 places. It's a less precise situation. All right? But this time they are out to 7 places. And let me tell you this right now. On the review, on one of the problems very, very, very close to the end, they did not round it to 7 places like they said. They messed up their 7th place. So if you happen to have your review handy, number 29, they have a 0. It should be a 1 at the very, very end. And I was like, what's the problem? Well, my calculator, maybe my calculator went to 7 places, and I thought, well, maybe they were looking at the next place and it rounded and whatever. And so I had to go online to find a calculator that would go beyond that many places just to double check, because you would think these people would be the right people. No, they're wrong. So in my key that I will eventually upload, where did I put that guy? I have a little note. The answer key rounded incorrectly on that one. Okay? Just saying. Did you think you could trust those people, right? Now, let's see how we get this stuff into the calculator. Some of it's super easy, and some of it, you're kind of like, well, how am I going to do that? So I'm going to start off out of order. I'm going to start off with number 12. Number 12, super friendly. I want the tangent of, well, we'll see how super friendly it is, a negative 80-degree 6-minute angle. Filippo, have you played with minutes and seconds? I think we had done that before you came to my class. Are you familiar with using minutes and seconds instead of decimals?
Yeah, but I did that. Hold on.
Okay, so since we get to use the calculator here, we can put it in. So let me show you how you're going to do it. So first of all, I'm just double checking my mode. Well, actually, I'm turning it on. My mode, I'm in degrees, right? To get out of any place you get into the calculator, if you want to get back to the home screen, you can quit. Anything that's on top in blue, so right above, I would do second, quit, and I'm back at the home screen. Okay? Sine, cosine, and tangent are right here on the face of the calculator. They know we're going to use them. They're right there. So I'm going to hit tangent, and I'm going to start typing what it tells me. Negative 80, because if there weren't minutes or seconds, I would not have to put in the degree symbol because the calculator knows I am in degrees, right? But I need that degree so that it separates it from the 6. So right where the mode is, you go down a couple. Do you see where it says apps? Above apps is angle. So second angle, and the first choice is a degree. You can just hit an enter because it's already highlighted, and look, you got a cute little degree sign, right? Then I'm going to type 6 minutes. So I go back to second angle, and number 2 is minutes. But I want you to notice there's not a double mark for seconds there. So we don't need it, but I'm going to show you where it is in just a second. So I'm going to write that. It is always a good idea, if a parenthesis is open for an argument, for you to close it. Hit enter, and here we go. So, what you looking at your watch? Like the bell not ringing? What, you trying to get out of here like real fast?
No, I was just bored, so I looked at it.
You're bored? Okay.
Word up.
You're bored?
Well, you were talking about things.
Stuff you already know. I'm so sorry, I'm boring you. Anyway, I might want to put an approximate because I am rounding it off. I never count off if you don't put approximate, but it's more proper, right? So they give me a -5, and I need 7 places, right? So 7, 2, 9, 7, 4, 1. That's 6 places. What am I going to do about the 6?
Oh, it rounds to the center.
Does it?
Wait, no, it doesn't.
Okay, it rounds to a 6, right? Okay, now, we'll stop right there. Filippo, if you ever need the double mark for seconds, it is down here above the plus sign in green. So you'd have to do alpha and get that. So they didn't add it to the menu because they already had one there for a different purpose. Okay, so you guys get crack-a-lackin'. Do your odd problems. 2, 2. All right. Let me stop this video. Somebody open the door because Ranger's probably already out in the hallway trying to get in here. And I have